All right, the goal of this video is to show you how to make a plot of some experimental data with a trend line and some of the idiosyncrasies that come along with plotting data. Let's get into it. I'm going to do a screen share here. Come on. And I need to stop this buffer over here. Hold on. All right. So typically what happens when you have a physics lab is you have some sort of equation. Let's say it's this equation right now. And this particular equation is talking about force and position. And there are some constants in this equation. Maybe our goal is to try and learn about those constants by doing an experiment. Well, so if you have this equation, it begs, what data do I need to plot? Well, in this case, I want force to be on the vertical axis and position to be on the horizontal axis. So I want some kind of data that looks like X over here and force up here. And then I can use a trend line to learn about the constants. That's our goal. Okay, let me get rid of some of these annotations, move things around a little bit. And let's say we have some data here. And here's the position data, and here's the force data. So again, this is a totally made up equation. Don't worry too much about the data. I just made up this data. It's all fake. You could ask, should I change these to millimeters and millinewtons? That would be a great idea. You could make a column here like this. Let's just say we do this. If I wanted to convert these to millimeters, all I'd have to do is say, oh, I need to either multiply or divide by 1,000. You can play around with it in your head. In this case, it turns to be times 1,000. So I could actually change the units over here. I don't want to do the plot with these units because then it's complicated for me to think about how those units affect the constants in my trend line. So you could ask me that in person during lab about what about the prefixes and units. Let's just get to the plot. All right, so in this case, we thought about the equation, got some useful data. We need to use a scatter plot, not a line plot. So let me highlight this data. I'm going to highlight just the numbers. You can I think you can highlight it with there too. Let's try that. Insert the scatter plot, not a line plot. Okay, now notice it puts this up here. This is just dumb. I don't know why it does that. So let's not do that. All right, so that's one way to do this. I'm going to show you another way to do it. Highlight the numbers in the first column. Notice my hands are not touching the keyboard. Now press and hold Control. And now I'm going to highlight the next column all in one swoop. And if I do that, that allows me to get two columns that are not right next to each other. I'm going to hit Insert, not the line plot. Line is terrible. Don't do that. That's only valid if your increment sizes are perfectly identical. In our real experiments, that's rarely true. We're going to do a scatter plot. All right, so there's two different ways to select the data. Are there others? Yes, sure. Now, the next question I want to ask is, should I use dots versus a smooth line? Generally speaking, you use dots for all experimental data. Okay, we use smooth lines for trend lines that come from ideal equations. Now, this data hopefully matches a trend line, but this is actually the data, not the trend line. So we want this to be dots. Exceptions, if you have more than 20, 30, 40 points, it might make, or if they're really close together, it might make sense to use a line in certain special occasions for your data. Here, I don't have much data. They're clearly separated. It makes sense to use dots. All right. Next, tick marks and or grid lines. More and more people are just getting rid of the grid lines and adding tick marks. So in this case, one thing you definitely have to do if you are going to use grid lines is to make them faint in the background, unobtrusive, something that doesn't interfere with someone's abilities to read the chart. So I'm going to hit Format Grid Lines. So let's say we actually wanted to use these. Maybe I'll use the lightest possible gray and dashed or something like this. Right? And maybe I'll do the same thing here. Whoops, you got to click on them. Make it thin and a light gray and dashed. So now I can see the grid lines just barely on my screen. You might have trouble and they might not print out very well, but they're just enough to guide the eye if you need it, but they're not so much that you have difficulty seeing the dots or where they're located. All right, next, we want to make sure your axis shows up well. So I might actually change this to black. and I'll change this to black. That way, if I have to print it, it's going to show up, right? Similarly, you might want to change these dots, change the color. Marker options. Let's see. Oh, let's go to the paint bucket here. Oh, I don't know. Crap. This is not what I was planning on talking about. That's what, now I'm all screwed up here. Oh, there we are. So there's the fill. So we could change the color to make it a brighter blue so it stands out. All right. And oh, we might want to change the line on there. Sorry about that. All right. Enough on the markers. You could dink around with that as you need to. I wanted to talk about, let's get back to what we're doing here. Tick marks. Sorry about that. I got off topic. So tick marks, we can go around, mess around in here and look for them. Tick marks. There they are. So I'm going to go down here and put in these ones. I'm going to put them inside. These ones, I'm going to put them across, and you just kind of decide what looks best for each situation. All right. So we've got, now what have we done? We've got the dots. We've done the tick marks. Font. I like to do the font early in the graph making process, because if you make a font and do some italics and do all kinds of stuff, then you go through and then you go back and make changes. Sometimes your changes will screw up other parts that you've modified. So I like to set the font early and forget it. So for me, I'm going to use Times New Roman. And notice I just clicked on the graph on the edge. I didn't do each one individually. You could click each one individually and change them that way, but it's faster, again, to do this for the whole graph at the beginning. So I'm going to do Times New Roman. If I was doing a presentation, I would do 18-point font. But this isn't a presentation, so maybe I'll just go back to 10-point font, whatever you're doing. And maybe I'll change the font color to black. And notice I'm going to hit undo. Watch the subtle difference here. It is something you notice, right? And especially if you're printing. If you don't change the font to black, sometimes it won't print very well. All right, so that's something to do. We're changing the font early, fixing the font size and color, and then we set it and forget it. Next, axis labels. How do you do that? One way is to come up here and we could hit axis titles. One of the things that drives me nuts about student work is people will put the axis titles on and then not change the Excel defaults. Drives me nuts. So Excel will go ahead and stick this axis floating out here. That's totally dumb. Let's not have the axis title floating out in space. This one is next to the axis. That's fine. My default for me is to always put one axis title. Oh, come on. Grab it by the edge, move it out. I like to have my axis titles at the positive ends of the coordinate system, because that's where we're used to looking for them. So I would put this up here. So two things that you might need to do. We might need to rotate this because it looks stupid. So let's format axis title. I believe it's in text options here, and we can just mess around with the rotation. All right, so there's that. Oops, make that a little bigger. And now down here, this one's kind of in the right spot. It's in the right orientation. I'm good to go. So now what do we title? Well, you may know from math class, it's always Y versus X, or vertical versus horizontal. I'll just say horizontal. So in this case, the vertical axis, another cool trick is you could actually look at the size of the frickin' numbers. Well, up and down, the numbers go from 0 to about 0.16. That's not X. That's going to be the force. So you could use the numbers to kind of see this, and we could say, okay, we could do this in one of two ways. We could say force in newtons. That's acceptable. And to be honest, a lot of people like this style. The style I grew up using was to instead use the variable. Here's an issue. If you use a variable, you put the variable in italics, the units are not italicized ever, okay? So I'm going to use this style. But again, in reports, a lot of times people are using the word force, which was not italicized, or in an oral presentation, definitely, you might just use the word, okay? It just depends on your usage. And here, like I said, you could do position in meters, and then make it so stretch things so you can see it. Or let's say you're going to put this in a report and you want to use the variable. I might use X. Because X is a variable, I italicize it. Control I is what I'm hitting there to do the italics. Now, a couple of notes on special symbols and things like this. Subscript. Okay, so variables versus words. Italics. It turns out we don't use italics on numerical subscripts or the delta symbol. If you're wondering how, let's say I wanted to call this, let me start over with this axis. Let's get rid of all the italics. I usually start with no italics, no formatting at all. Let's say I wanted to use DX1 instead. So change in position 1. If I want to do a subscript, I can highlight the number, right click, font, subscript. You could also do superscript there too. Do you see that? Okay. And then I could do the delta symbol. My trick is to highlight that, and then we want to go to symbol font. So rather than searching for it, I type SYM, symbol pops right up. That's the Greek letters. Now, again, the delta symbol is not italicized, neither is the number in the subscript, but usually letter subscripts are italicized, things like that. So here, the variable still needs to be italicized. That would be a correct way to label this. All right, so that said, let's just go to X and let's get rid of that font. Type TIM for Times New Roman, italics, whoops, italics that. All right, so there we go. We have now talked about the font. We've talked about the axis labels. We've done all this super and subscript. Now, do you actually need a legend or a chart title? In this case, we do not need a chart title, okay? The chart title is useful if we have a specific case. So maybe if I was doing force versus position for car 1, because maybe there's multiple plots in a report that one's for car 1, one's for car 2, then it might make sense to put a title on it, so you know, or maybe a caption, and we could discuss that too in lab if you actually care. But one thing that you don't do is you don't put something like this. You wouldn't say something like this. I see this a lot with students: force versus X in meters. We don't put the units in the title. It drives me nuts. Right? The units are supposed to be on the axis labels. So you would never title something like this. You could title something like this, but then because these are variables, you would have to italicize them. But again, why would you waste time on this when the axis labels make that clear and there's only one data set? So think carefully. Do you need a legend if you have more than one data set? Sure. Or do you need a title, perhaps, if it's a certain special case? But if you have one data set and the axis labels are clear, you usually don't need a title. And that has an advantage because now I can stretch this and make it a little bit bigger and easier to read. We're trying to make things easier for the reader. So there's that. Now, finally, we're up to the trend line. We did all this work to make this thing look pretty. Maybe I'll put a trend line on here. There's two ways to do it. You can come over here and click add a trend line. Notice the default is linear. Okay. Or we could right click, add a trend line. And when it does that, I think it's really important. Students oftentimes think everything should be a linear trend line. That's just not true. In particular, our force equation was quadratic. So our trend line here should not be linear. It should be, whoa, where we go? There we go. It should probably be a polynomial. And I love, it cracks me up when students say, oh, it's exponential. Students call everything exponential for no reason. I don't understand why, but the most common trend lines are linear or polynomial order 2. Sometimes there's exponential, but don't say things are increasing exponentially if it's quadratic, right? That just doesn't make sense. All right. When you click on the trend line, several things need to be done. One, you should immediately scroll to the bottom and display the equation so we can actually get something useful out of this. And whoops, let's go back to the trend line. Whoops, let me click the trend line here. Scroll down. We should also display the R² value on the chart. If you want to understand what that means, I'm sure you could do a Google search, but essentially the closer R² is to 1, the better this type of trend line fits this particular type of data. You could come in here and change all these to force right here, and we could hit some italics, make some cosmetics here. All right. And now maybe what I'll do, just to do some color coordination, if I was doing a report and I used red somewhere, why don't I use red everywhere? So let's make this red. And why don't I make this trend line red? So I could come into here and make it red. And maybe I'll make it solid so that it's easier to see. and make it a little bit thinner so it's not covering up all of the data. So here we have some cosmetic work that kind of looks nice. We've color coded things. We've done some italics. Okay, great. At the beginning of this video, we said, hey, how can I get the constants here? Well, now I think we can do that. And let me get a nice color here. Look, A is the constant term in the trend line. That tells us a value for A. Negative K is right here. So notice negative K is on the linear term. That tells us that K is it's not negative 0.153, it's 0.1573. Again, the minus sign is in the equation. So you got to look carefully. There's a minus sign here. There's a minus sign right there. That's why K is this number. All right. And now we got to be extra careful on this last term. 1/2 of B is this. So you could set this number equal to 1/2 of B is equal to what? 0.8154. Now that we know what half of B is, you could use that to figure out B looks like it's about 1.6 or something like that. Okay, so that's how you can use the trend line to learn about these coefficients. Now let's go just a little bit farther here. That's the bulk of it. If you wanted to stop now, you could, but I think there's a few things that are probably worth hearing. I'll try and make it quick. Now, slope, if you have a linear fit, obviously I don't have a linear fit here. There's another way to get the slope. You could just say equals slope, highlight the y values, comma, highlight the x values. Now, since this data is nonlinear, this doesn't really make sense, but that's a quick way to get the slope. Another thing you can do is hit LINEST, and this not only gives you the slope, but it gives you the error in the slope, statistical error, and it gives you the intercept and the error in the intercept, which is very convenient. It tells you basically where to round the digits. I have a separate video on that, so I'll let you watch that separate video in the playlist. I think it's playlist video 4 or something like that. All right, so that takes care of this. Finally, another thing that you want to do with any of these plots is you usually want to save a template. So we could save this as a template, and maybe I'll say this is Rob's experimental with Trendline. All right, great. And so the idea is, why do this? Check out this huge advantage. Okay, we got this plot here. We're going to move this up here. Now let's say I want to do this data again, or a new data set, insert a scatter plot, right click, change the chart type, and I could use a template. And I think, I have a bunch of different types of templates here for different types of situations. And so now I've already got most of my information, right? I might have to go in here and format the trend line and display it's not displaying it. There it goes. So I might have to display the equation on the chart again, do a little dinking around there, and might have to fix the bounds and axis labels, but most of the work is done. So setting a template can save you tremendous amounts of time. You can make a template for each different teacher. Finally, a classic thing to do is, in this problem, there's not that much wasted space, but you might want to go in and change the bounds or the sig figs, things like that. So in order to do that, we could, let me click this, format the axis. You could come down into here. You could change the number of sig figs on the axis. Let's say we only need 2. And maybe I just want to go from negative 0.25 to positive 0.25. And something weird happens here. Look at this increment. This is terrible. The first increment goes by 0.05. Then the next one scoots over an additional 0.1. That's a really bad style. You got to watch out for this. Excel doesn't know that you wanted to go by 0.05. And when I do that, now the increments are all identical. And again, I could change the vertical. Maybe I'll just go here. Let's go to 0.14, I think. And so what I've done, I know this doesn't seem like much, is I've made the graph proportionally take just a little bit more of the blank white space. I basically removed some of the blank white space, right? And this is another reason it's kind of nice to use variables instead of words. You could squeeze stuff out more. And as a result, in the back of the classroom, or if you're giving a presentation, things are just a little bit bigger, and that might be just enough to help somebody read something. So let's go through this again really quick. Think about the equations. I think we've got it all. All right.